Exponential Trend Forecasting, prepared by Professor Amit Tata School of Business, George Mason University. Sometimes the time series for which you are doing the forecasting exhibits a nonlinear trend. For instance, if you look at column C here, which shows 10 years worth of revenue data, when that revenue data is plotted, as you can see in the chart on the right hand side, the pattern that's evident clearly shows a nonlinear trend. There are many different nonlinear functions that could be used to approximate these trends, and a very commonly used one is what's called an exponential function, as you see in the expression at the just below the table there, which says revenue is equal to a coefficient b0 multiplied by another coefficient b1 raised to the power year. So the independent variable of the time dimension appears as an exponent in this expression. That's where the term exponential trend comes from. So how would one go about approximating the trend in this time series using this kind of an exponential function? So let me move this chart out of the way. So the first thing that one does is you take the logarithms of both sides. You could take logarithm to any base, but we'll just take the natural logarithm here. So if you take the natural logarithm of the left hand side and the right hand side of this equation, you get natural log of revenue is equal to natural log of b0 plus natural log of b1 multiplied by year. So you can see it has become a linear expression. This small transformation that we did converts that exponential expression into a linear one, and then one can go about using simple linear regression to estimate these logarithmic coefficients and then sort of reverse engineer the coefficients b0 and b1 from that. So let's see how one would go about doing that. First step, of course, is we need to transform our revenue into logarithm of revenue. So that's what we're going to do. There's the heading for this column, and the transformation will be done as follows: equal to ln. This is the Excel built-in function for the natural logarithm of 23.1, and there you have the first year's transform value, and I copy the formula down and get the natural log of all the revenues for the 10 years. Okay, so now if I do a linear regression of this logarithm of revenue against column B against year, I would get an intercept and a slope, which would give me natural log of b0 and natural log of b1, and then I would do some reverse engineering from there. So let's do our next step, a linear regression of column D versus column B. Okay, so I do data analysis. I bring up the regression function. My dependent variable, of course, is the natural log of revenue. My independent variable is time, which in this case is year, and we will put our output in, let's say, column G2. So there we have our output, and based on the coefficients that you can see over here, we can see that the natural log of b0, which is the intercept, is 2.81, and the natural log of b1 is 0.17, rounded off to two decimal places. So where did 2.81 and 0.17 come from? These are the two coefficients here. 2.81 is here, the intercept, and 0.17 is the coefficient for year. Okay, so again, let me increase the size of these so you can see them a little better. All right, so how do I reverse engineer b0 and b1 from this? That's pretty easy. b0 would be equal to e to the exponent, so e to the 2.81, and B1 would be e to the 0.17 0.17. So there you have the values for B0 and B1. Okay, so we have reverse engineered B0 and B1. Once we have all the different pieces together, we can recreate our exponential trend expression, which would be revenue is equal to 16.61 multiplied by 1.19 to the year, raised to the power year. So let me do a little. Okay, so there we have our expression. So revenue is equal to 16.61 times 1.19 raised to the power year. So this is my exponential approximation for the nonlinear trend that was evident in the expression in the time series. Okay, and if you give me year, so if I wanted to make a trend forecast for year 11, I would just plug in the value 11 into this expression, and I would say revenue is equal to 16.61 multiplied by 1.19 raised to the 11. So once I have the expression, the exponential expression estimated, the coefficients estimated from the time series data that has been given to me, you can use the trend to do your forecasting. As with other kinds of trend forecasting situations, one can take this trend equation and use that to detrend the raw data, and then have a second component of the forecast where one looks at the random components and then maybe uses time series or moving average to forecast the random portion, and then synthesize that together with the trend and come up with the composite number, which is a better representation of a better estimation of the forecast that one would have. But that's a different story. In this module, I simply wanted to show you how, when a nonlinear trend is present in the time series, how one could use an exponential type of expression to approximate the trend for forecasting purposes.